In this video, we'll look at reactions that involve the transfer of electrons. Let's look at the formation of alumina, Al2O3, from solid aluminum and oxygen gas. The product is an ionic compound comprised of 2 aluminum-3 ions and 3 oxide ions. Let's look at the change in each of the elements in this reaction individually. Which of the following correctly describes the change occurring to the aluminum? Because aluminum is the cation in an ionic compound, it loses electrons. Aluminum has 3 valence electrons and it will lose all of them to become a cation. Its resulting charge is +3. We can describe this process by writing what we refer to as a half reaction. Aluminum yields aluminum 3+. Notice that, written this way, there are not the same number of electrons on both sides of the equation. How can we fix this? As it's written now, the equation is not balanced with respect to the electrons on each side. If we were to draw the Lewis structures for both species, we see that the aluminum on the reactant side loses 3 electrons. We must therefore write these electrons on the product side, the right side, to have a balanced half reaction. We call this process, that of losing electrons, oxidation. In this case, the aluminum is being oxidized to aluminum 3+ because it loses electrons. Now let's take a look at the other species in this reaction, oxygen. Which of the following correctly describes the change occurring to the oxygen atoms in O2? Since these reactions happen in pairs, if aluminum is losing electrons, then something must be gaining them. That must be the oxygen. In the oxygen molecule O2, each atom will have 6 valence electrons. If we were to pull them apart, their electron configuration would be helium 2s2 2p4. So, to achieve noble gas configuration, oxygen must gain 2 electrons and its resulting charge is -2. We can write this half reaction, O2 yields 2 O2-, to describe this process. Notice that, once again, there are not the same number of electrons on both sides of the equation. How can we fix this? In this case, we must add 4 electrons to the left side of the equation, as oxygen will gain 2 electrons to become O2-. The process of gaining electrons is called reduction. The oxygen atoms in O2 are being reduced to O2-. They are gaining electrons. We could have also balanced this half reaction by inspection of the charges of both sides. The left-hand side of the half reaction has no charge, and the right-hand side of the reaction has a charge of -4. When we learn to balance equations, we emphasize that all of the atoms on the left-hand side must match the atoms on the right-hand side of the reaction. That remains true. Here, we add one more detail. The total charge, which is related to the number of electrons, must also remain the same. So what could we do to make the charges on both sides the same? While subtracting 4 electrons from the right might make mathematical sense, chemical equations only ever use addition, so that's not an option. So all we can do is add 4 electrons to the left. And there we have it, our reduction half reaction. Oxidation only occurs because something else is being reduced. After all, those electrons need to go somewhere. In this case, aluminum is losing 3 electrons and the 2 oxygens are gaining 4 electrons. So how can we resolve this? It's not possible to take an extra electron from aluminum. It's also not possible to make one of the oxygen atoms electron deficient. However, what we can do is multiply one or both of the half reactions until we have a common number of electrons transferred between the species. If we multiplied the oxidation half reaction by 4, we get that 4 aluminum yields 4 aluminum 3+ plus 12 electrons. The reaction is still balanced because we multiplied the whole reaction by 4. What factor should we multiply the reduction reaction by to balance the number of electrons transferred between species? If we were to multiply the whole reduction reaction by 3, the result would be 12 electrons plus 3 O2 yields 6 O2-. The oxygen atoms gain a total of 12 electrons, which is the total number of electrons lost by the aluminum atoms. As a result, the half reactions are now balanced with respect to electrons too. We are now able to put our half reactions together to write the following equation to describe the reaction between aluminum and oxygen. 4 aluminum plus 3 oxygen yield 2 aluminum. It can be a little tricky to memorize what these new terms, oxidation and reduction, mean. You can use the following mnemonic to help you. Leo the lion says grr. A species that loses electrons undergoes oxidation, and a species that gains electrons undergoes reduction. Keep this in mind when practicing oxidation-reduction reactions.